Imagine floating alone in the darkness of space, with nothing and no one around for light years. This is not just a sci-fi dream, it's the reality for a star, so isolated it's been dubbed the loneliest star in the universe. Today, we'll uncover the mystery of this distant celestial outcast, explore why it's so far away from its cosmic neighbors, and what it can teach us about the universe. The loneliest star we're talking about is 2MASS J523 1403. Unlike the bright stars you see in the night sky, this is a red dwarf star. It's faint, small, and completely isolated around 40 light-years from Earth. While that may seem close by astronomical standards, what makes this star fascinating is that it exists in a region of space with almost no other stars nearby. Think of it as the introvert of the cosmos, quietly glowing in solitude. Scientists believe 2MASS J523 1403 ended up alone due to its formation. Stars usually form in clusters, but not every star stays with its siblings. Over millions of years, gravitational interactions, collisions, and galactic drift can separate stars from their original families. For 2MASS J523 1403, the journey left it stranded in an area of space where few stars have ventured. Its low mass and dim light likely made it an easy target for ejection from a star cluster. Despite its loneliness, 2MASS J523 1403 continues to burn hydrogen just like any other star. Red dwarfs like this one are incredibly efficient and can live for billions if not trillions of years. This star's dim glow is just enough to keep it alive, even though it receives no heat or light from neighboring stars. It's a testament to resilience, showing how even the smallest stars can endure in the harshest conditions. Lonely stars, like 2MASS J523 1403, offer unique insights into the dynamics of our galaxy. Their isolation challenges our understanding of star formation and galactic evolution. By studying such stars, astronomers can trace the history of stellar movements and interactions across the Milky Way. Additionally, these stars might harbor planets, raising questions about the possibility of life in extreme solitude. What kind of life could evolve without the energy of a nearby sun? There's something hauntingly beautiful about a star existing entirely on its own. It reminds us of the vastness of space and our tiny place within it. The loneliness of 2MASS J523 1403 is a metaphor for resilience and survival against the odds. In a universe filled with billions of stars, it stands as a silent witness to time, quietly burning in the void. It's a poignant reminder that even in isolation, there is light, however faint. Discovering stars like 2MASS J523 1403 isn't easy. This star was found using infrared surveys, which are ideal for spotting dim, cool stars like red dwarfs. Infrared light can penetrate dust clouds and reveal celestial objects that are invisible in optical light. The 2-micron all-sky survey, 2MASS, was instrumental in this discovery, giving astronomers the tools to detect such a faint star in the vast darkness of space. Red dwarfs like 2MASS J523 1403 belong to the M dwarf class of stars, which are the smallest and coolest stars on the main sequence. They are incredibly common, accounting for about 70% of all stars in the Milky Way. However, their low luminosity means they are often overlooked, even though they outnumber brighter stars like the Sun. Unlike massive stars that burn through their fuel quickly, red dwarfs have a slow and steady nuclear fusion process. This means they can sustain themselves for trillions of years, far longer than the universe's current age. In fact, no red dwarf has ever died of old age yet. 2MASS J523 1403 emits very little light, so much so that it can only be detected with specialized instruments. Its faintness highlights the challenge of studying such stars and raises questions about how many similar stars might remain undiscovered, hidden in the shadows of the cosmos. While no planets have been detected around 2 MASSJ 523-1403 yet, red dwarfs are known to host planetary systems. Planets around such stars often exist in tight orbits due to the star's low mass and gravity. If this star has planets, they could be icy, rocky, or even harboring atmospheres despite the faint light. Stars like 2 MASS J523-1403 are sometimes referred to as stellar wanderers due to their isolation. Over billions of years, gravitational forces can cause stars to drift far from their original locations, leaving them stranded in cosmic voids like this one. The isolation of a star can influence its evolution in surprising ways. Without nearby stars to interact with, 2 MASS J523-1403 evolves in relative peace. It avoids the gravitational disruptions or radiation pressure that stars in dense clusters often experience. The region of space surrounding 2 MASS J523-1403 is remarkably empty, but this void also provides a window into the interstellar medium, the gases and dust that fill the space between stars. Studying this environment can reveal clues about star formation and the early days of our galaxy. Our Sun is a yellow dwarf, much larger and brighter than 2 MASSJ 523-1403. While the Sun supports a dynamic solar system with complex interactions, 2 MASSJ 523-1403 exists as a faint, solitary light. This stark contrast highlights the diversity of stars in our universe. If intelligent life existed elsewhere in the galaxy, would they notice a star as faint as 2 MASS J523-1403? Its low brightness makes it unlikely to be a target for alien astronomers, raising fascinating questions about what we might overlook when searching for life ourselves. The loneliness of this star captures the essence of the universe: vast, mysterious, and often silent. Its solitude serves as a cosmic reminder of how small and connected we are as inhabitants of a tiny planet in an infinite expanse. 2 MASS J523-1403 challenges the traditional view of stars as being part of bustling galactic neighborhoods. It raises questions about the mechanisms that separate stars and the long-term effects of such isolation on their life cycles. Gravitational interactions are one of the primary forces shaping the paths of stars. Over billions of years, even minor gravitational nudges can alter a star's trajectory, potentially leaving it stranded like 2 MASS J523-1403. Despite decades of study, the exact origin of 2 MASS J523-1403 remains unknown. Was it part of a cluster that dissolved? Or was it born in isolation? Answering this question could unlock new insights into stellar dynamics. Astronomers are always on the lookout for stars like 2 MASS J523-1403. Advanced surveys and telescopes, such as the James Webb Space Telescope, are pushing the boundaries of our knowledge, allowing us to uncover even more of these cosmic hermits. Some theories suggest that black holes or other massive objects could eject stars like 2 MASS J523-1403 from their clusters. By studying such stars, we might better understand the role black holes play in shaping our galaxy. If 2 MASS J523-1403 were as bright as the Sun, it wouldn't be considered lonely. Its brightness would attract attention from Earth and perhaps even other civilizations. Its faintness, however, leaves it hidden from all but the most advanced technology. Even in isolation, 2MASS J523 1403 continues to burn, a beacon of resilience in the void. It reminds us that life, energy, and existence can persist even in the most desolate conditions. While 2MASS J523 1403 is relatively close at 40 light-years, reaching it would require advancements in space travel technology. A probe sent today would take thousands of years to arrive, but such a mission could reveal incredible insights. Many stars form as binary or multi-star systems, but over time, gravitational forces or collisions can separate these companions. It's possible that 2MASS J523 1403 once had a partner that drifted away or was ejected, leaving it to shine alone in the cosmic void. 2MASS J523 1403 is a low-mass star, which means it lacks the violent flares and activity of larger stars. Its relative calmness allows it to sustain itself steadily over an incredibly long lifespan. This stability also makes it a potential candidate for studying long-term stellar evolution. Throughout history, humanity has often attributed meanings to stars. A lone star in the sky might be seen as a symbol of solitude, resilience, or even guidance. The poetic nature of 2MASS J523 1403 reminds us of how celestial objects inspire stories and emotions across cultures. Stars like 2MASS J523 1403 were nearly invisible before advancements in technology. Instruments such as infrared telescopes and sensitive detectors allow us to study their characteristics. Without these tools, much of the universe's faint population would remain hidden. While 2MASS J523 1403 is currently isolated, the universe is always in motion. Over millions or billions of years, it could drift closer to another star system or pass through a more densely populated region of the galaxy, creating new interactions. By analyzing the light spectrum of 2MASS J523 1403, astronomers can uncover details about its composition, temperature, and age. Spectral analysis is like taking the star's fingerprint, revealing everything from its metallicity to its evolutionary stage. If 2MASS J523 1403 has planets, they would exist in a tight, habitable zone due to the star's dim light. Life on such planets would need to adapt to faint energy sources, possibly relying on geothermal heat or other unconventional methods for survival. Isolated stars like 2MASS J523 1000 have gone supernova. The identification of 2MASS J523 1403 has expanded our understanding of the types of stars in the galaxy. It highlighted the need for more infrared surveys and inspired the search for similarly hidden objects in remote parts of space. Rogue planets, those not bound to any star, could theoretically pass close to 2MASS J523 1403 and temporarily orbit it. Such interactions would provide a fascinating scenario for astronomers to study the dynamics between lonely stars and wandering worlds. Over billions of years, stars like 2MASS J523 1403 slowly drift through the galaxy due to gravitational interactions. This movement reshapes the Milky Way's structure, proving that even isolated stars are part of the galaxy's grand choreography. Advanced civilizations might one day reach stars like 2MASS J523 1403 to harvest its energy. Its long lifespan and steady output could make it an ideal target for constructing megastructures like Dyson spheres or other energy-gathering technologies. Billions of years from now, 2 MASS J523 1403 will continue to burn quietly, outliving stars like the Sun. Eventually, it will cool into a faint white dwarf, becoming a relic of a bygone era of the universe. In literature and art, a lone star often symbolizes longing, guidance, or perseverance. 2 MASS J523 1403 embodies these qualities, standing as a solitary light in the endless void of space. Every star in the galaxy, including 2 MASS J523 1403, adds to the incredible diversity of the cosmos. Studying this star helps us appreciate the wide range of celestial objects that make up our universe. The story of 2 MASS J523 1403 inspires scientists and dreamers alike to continue exploring the unknown. Its quiet persistence reminds us that even the most remote corners of the universe hold secrets worth uncovering. Because red dwarfs like 2 MASS J523 1403 live for such an incredible length of time, they act as cosmic fossils. They preserve the conditions of their formation, offering a window into the past of the galaxy and the universe as a whole. Stars like 2 MASS J523 1403 often exist in what astronomers call galactic isolation zones. These are vast regions of space with few stars or other celestial objects, creating environments where stars seem to float in eerie solitude. Every star emits light at specific wavelengths, creating a spectral signature. 2 MASS J523 1403 spectrum not only reveals its composition, but also offers clues about its temperature, magnetic activity, and even its rotation speed. Red dwarfs like 2 MASS J523 1403 are inherently faint, emitting most of their light in the infrared spectrum. This makes them nearly invisible to the naked eye and challenging to detect without advanced infrared telescopes. If a nearby star were to go supernova, it could briefly illuminate the surroundings of 2 MASS J523 1403. However, its isolation likely protects it from such cosmic explosions, preserving its quiet existence. The star's isolation may actually contribute to its longevity. In densely packed star clusters, interactions can strip stars of their material or disrupt their stability. For 2 MASS J523 1403, solitude is a shield, ensuring its slow and steady life cycle. While its exact age is unknown, 2 MASS J523 1403 could be several billion years old, possibly older than our Sun. Its age provides clues about the conditions under which it formed and the era of the galaxy it originated in. The idea of a lonely star prompts deep philosophical questions. What does it mean to exist in solitude? How does this reflect on humanity's search for meaning in the universe? 2 MASS SJ 523 1403 serves as both a scientific and existential curiosity. Up close, 2 MASS J523 1403 would appear as a dim red glow, far less brilliant than our Sun. Its surface would be relatively cool, with temperatures allowing the formation of molecules that don't exist on hotter stars. In the far future, if a rogue planet were captured by 2 MASS J523 1403, it could potentially become habitable. Its long lifespan makes it an excellent candidate for sustaining stable conditions over immense timescales. 2 MASS J523 1403 is a prime example of why astronomy is so challenging. Faint stars require long observation times and highly sensitive instruments, pushing the boundaries of technology and human ingenuity. Red dwarfs like 2MASS J523 1403, have smaller habitable zones than stars like the Sun. Studying this star helps refine our understanding of where life might exist around low-mass stars in the galaxy. Some stars that seem isolated may actually be part of larger stellar structures that are difficult to detect. Astronomy, or a remnant of a dissolved cluster. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.